This phrase introduces the core concept of the quiz problem. K-fold cross-validation, a method used to evaluate machine learning models. It's like testing a recipe 5 different times, each time with a slightly different set of ingredients, data samples, to see how reliable it is. Here, we have 25 samples of data and will divide them into 5 folds, groups. K-fold cross-validation is a technique used to divide a data set into multiple folds for training and testing purposes, to get a better evaluation of machine learning model performance. In this case, K equals 5. This is the total amount of data we're working with. Think of it like having 25 recipe ingredients to test your recipe model. One of the 5 groups we split the dataset into. In each of the 5 folds, 1, 2, 3, 4, 5, some of the dataset will be used for the training of the machine learning model and the rest will be used for its testing. This is one iteration of the machine learning model training process, where only a portion of the data is utilized for training and testing. Another group, like fold 1, also containing a portion of the original dataset used for training and testing. Similar to fold 1 and fold 2, each fold is independent and contributes to a comprehensive evaluation of the model's performance. This is another iteration, similar to fold 1, fold 2, and fold 3. This division helps to understand how consistently the model performs across different subsets of the data. Another independent iteration. The last group, similar to the previous folds. The results from all 5 folds are usually aggregated to provide a more robust estimate of the model's performance. One more independent iteration. In each fold, the training set includes 20 out of the total 25 samples. This set is used to train the machine learning model in each fold. Imagine you use 20 ingredients to learn how to make the recipe better. The remaining 5 samples in each fold are used to test how well the model performs after training. After training, you use the remaining 5 ingredients to test how good the recipe became. This refers to the total number of data points used in the cross-validation experiment. The scikit-learn's KFold will divide these 25 samples into training and testing sets. It's a crucial piece of information for understanding the size of the folds and how many samples are in each. This describes the process of dividing the dataset into training and testing sets. In 5-fold cross-validation, the data is split into 5 distinct parts. Each part serves as the testing set once, while the remaining 4 parts are combined to form the training set. This iterative process allows for more robust model evaluation and helps to prevent overfitting. How this splitting is done is described further in the following rows. This question presents a scenario where scikit-learn's KFold is used for 5-fold cross-validation on a dataset with 25 samples. It asks you to identify true statements about the resulting data splits. Scikit-learn is a popular Python library for machine learning, and KFold is a technique to split data into training and testing sets to evaluate model performance more robustly than with a single train test split. The key here is understanding how KFold divides the data. This statement asserts that each fold in the 5-fold cross-validation will have precisely 5 samples. Let's think about it. With 25 samples and 5 folds, a simple division, 25 samples, 5 folds equals 5 samples, fold, suggests this is true. However, KFold doesn't always guarantee this perfectly for datasets where the number of samples isn't perfectly divisible by the number of folds. This is mostly true in this case but not necessarily true in other cases. This statement claims that each sample in the dataset will be used once as a test sample and in all the other folds as a training sample. This is a core property of KFold cross-validation. It's designed to ensure every sample gets its moment in the testing spotlight, preventing bias from some samples being consistently in training and others consistently in testing. Here, the assertion is that each training set will have exactly 20 samples. Let's analyze. Since there are 25 samples total and each fold uses 5 samples for testing, as discussed in option A, the remaining 20 samples, 25 minus 5 equals 20, are used for training in that particular fold. Therefore, this statement is true. This statement suggests each testing set, each fold, will contain exactly 5 samples. Similar to option A, while this is the ideal scenario with 25 samples and 5 folds, it's not a strict guarantee of KFold for all datasets. If the number of samples isn't perfectly divisible by the number of folds, some folds might have a different number of samples than others. Imagine you have 26 samples and 5 folds. One fold would need to have 6 samples. This describes the method used to split the data. KFold cross-validation is a technique to evaluate a machine learning model's performance by splitting the data into K groups, folds. Here, we have 5 folds and a total of 25 samples. We'll see how this affects the training and testing sets. This is the total amount of data. We're working with 25 individual data points. This is the dataset that will be split into folds for cross-validation. One of the 5 groups, folds, created from the dataset. Each fold will be used once as a testing set, while the remaining folds form the training set for that specific iteration. This first fold contains 5 samples, and its corresponding training set contains the remaining 20 samples. Another group, fold, of 5 samples, serving the same purpose as fold 1, used once as a testing set. The remaining 20 samples create the training set for this iteration. The process is repeated for all 5 folds. Similar to fold 1 and 2. It's another set of 5 samples that make up the testing set for this specific iteration. The remaining 20 samples make up the training set. Another set of 5 samples, forming a testing set for this iteration. As usual, the other 20 samples serve as the training set. The final fold with 5 samples, again used as the testing set. In this iteration, the remaining 20 samples constitute the training set. In each iteration of 5-fold cross-validation, 4 of the 5 folds are combined to form the training set, containing 20 samples. This set is used to train the machine learning model. In each iteration, one of the 5 folds is used as the testing set, consisting of 5 samples. This set is used to evaluate the model's performance after training. This is a key property of KFold cross-validation. Each data point is used once for testing and in all the remaining training sets across the 5 iterations. This ensures each data point contributes to both the training and evaluation of the model. That's fairness in action. Okay, so we're doing a 5-fold cross-validation. This means we'll split our 25 samples into 5 different groups, or folds, for training and testing our model. This is a common technique in machine learning to assess how well a model generalizes to unseen data. Okay, so we're doing a 5-fold cross-validation. This means we'll split our 25 samples into 5 different groups, or folds, for training and testing our model. This is a common technique in machine learning to assess how well a model generalizes to unseen data. This is the core question, VOMC. We're asked to identify which statements are true concerning the dataset's splitting. Let's analyze each statement carefully and see what we come up with. This is the core question, VOMC. We're asked to identify which statements are true concerning the dataset's splitting. Let's analyze each statement carefully and see what we come up with. Our dataset is made up of 25 individual samples or data points. This is the total number of observations we'll split across 5 folds. It's like having 25 cards, and we'll deal them into 5 hands. Our dataset is made up of 25 individual samples or data points. This is the total number of observations we'll split across 5 folds. It's like having 25 cards, and we'll deal them into 5 hands. The K in KFold cross-validation refers to the number of folds. Here, K equals 5, which means 5 folds. Each fold will take a turn acting as the testing set, while the rest are used for training. The K in KFold cross-validation refers to the number of folds. Here, K equals 5, which means 5 folds. Each fold will take a turn acting as the testing set, while the rest are used for training. As mentioned, there will be a total of 5 folds, each with a portion of the data. This creates 5 different sets of training and testing data. This helps us get a more robust estimate of the model's performance. As mentioned, there will be a total of 5 folds, each with a portion of the data. This creates 5 different sets of training and testing data. This helps us get a more robust estimate of the model's performance. In each fold, 20 samples, 25 total 5 testing samples, are used to train the model, and the remaining 5 samples will be used to test the model. This is the fundamental setup of KFold cross-validation for this quiz question. In each fold, 20 samples, 25 total 5 testing samples, are used to train the model, and the remaining 5 samples will be used to test the model. This is the fundamental setup of KFold cross-validation for this quiz question.